Impedance measurement is important for improving the performance of electrolytic cells. This video shows the impedance measurement of an electrolytic cell using the ALDAS-Mini. Check that the source module is turned off before wiring. Connect the power cord to the source module. Connect the source module to the sense module with the bundled power cord. Connect the source module to the sense module with a LAN cable. Connect the source module to a PC with a LAN cable. Plug the USB key into the PC. Connect the banana terminals of the sense cable to the sense module. Connect the alligator clip of the sense cable to the cell terminal. For a cell stack, multiple channels can measure each cell simultaneously. The largest model can measure up to 8 channels. Connect the source cable to the connector on the back side of the source module. Connect the clips of the source cable to the positive and negative sides of the cell. Connect the current sensor connector to current channel terminal 1 on the sense module. Clamp the current sensor around the DC power line. Start the application software. Create a new project. Set a name for the project. Check the connection between the PC and ALDAS-Mini. Connection successful. Select the EIS mode in the measurement type settings. Configure the measurement condition settings. Set the measurement speed, noise reduction filter, and applied current level. Configure the frequency settings. Check the boxes to select measurement channels. Select the current range according to the cell's maximum electrolytic current. Set phase correction function to auto. Finally, enter the cell size. Review the settings. Select the graph type to display. Let's get started with the measurement. Measurement complete. Continue measurement under multiple conditions by changing the electrolytic current. Since multiple measurement results are displayed simultaneously, you can instantly see how different conditions yield different readings.